Right, so let's look at section 2 of this paper, and it's all about, in this case, blocks of chairs. Read carefully, okay, because you need to make sure you carefully check what you're doing here. Dimensions of the blocks of chairs. Okay, now one of the things unfortunately I can't show is really with the mouse moving around, but what I need you to draw your attention to is on the diagram where we've got the stage and chairs left and chairs right. It's very important to be mindful of the 2 meter gaps, right? Because that is going to affect your answer. So if we just take a look at just the one block, left block of chairs at the moment, they want the dimensions. So we have 14 meters from the stage to the back of the hall, but you'll notice either side, either end, there's a 2 meter gap on the chairs, right? So our length is going to be 14 meters take 4 meters, or 2 meters and 2 meters, which gives us 10. The same applies to the width. So what we're actually doing here is we're talking 20 meters here. We're looking at 20 meters here. And what you can actually see either side, if we're looking from left to right, there's 3 lots of 2 meters. So we need to take that 3 lots of 2 meters away from the 20 meters. That's giving us now the width of the 2 blocks of chairs together, if we see what I mean. We always like crunch them together, we're taking the distance out. But there's 2 blocks, so we need to divide that 14 meters by 2, which makes essentially each chair block 7 meters wide. You might just want to put on pause and just have a look at how that question is structured, how the answers come together, and just reflect on that diagram here with the chairs left and right block. Again, this type of question has been known to pop up in different guises, like perhaps boards around the outside of a games pitch or something like that. So that is worth a question, just worth spending a little bit of time looking at. Okay, so how many chairs will fit in a row across one block? Well, one block is 7 meters width. One chair, we are told, is 47 centimeters in width, or 400 centimeters, and we can see that in the diagram on the right hand side where they give the measurements of the chair. The answer will need to be in centimeters. So 7 meters is going to become 700 centimeters. 700 centimeters divided by 47 gives 14.89 chairs. The reason I'm saying that is because your chair widths in meters make your life simple. Or sorry, centimeters. Millimeters we're converting into centimeters. Right, so put everything in centimeters, make your life straightforward. Right, it's easier figures to deal with. So 14.89 chairs. We can't have an 89th of a chair, so our answer is 14. How many chairs can we set out for the audience? Okay, remember 30 centimeters of leg room in front of each chair here. It says this down just below diagram. There should be leg room of at least 30 centimeters in front of each chair. Be aware of the at least part. Okay. Answer will need to be in meters, so we need about 30 centimeters into 0.3 meters. Okay. 40 centimeter chair width becomes 0.47 meters. Remember, 100 centimeters equals a meter. Add those two together. That will give us our actual width of the chair, which is 0.77 meters. Length of chair blocks we know is 10 meters. So we divide the 10 meters and 0.77 together. 12.98. Now in this case, you're going to go to 13 rows. That's what you will do on this particular case. It's going to be 13 rows because it's going to work with the measurements that we've actually got. So we can go for that. 13 chair rows times 14 chairs in a row is 182 per block. 182 times 2 equals 364, which is the amount of total chairs that are going to be needed. So again, you just might want to have a little look through on this question and see how it all breaks down into little constituent parts and actually comes together. Okay, this is a little bit of a strange question. I had to do a little bit of research on the internet myself on this one, which I know you can't do. But this is, I think, in the end, is something that you know or you don't know. And you'll just have to make an appropriate guess to it. It's a very vague question. And what load in kilograms can someone of your age carry? Well, my viewpoint on that, looking at health and safety, being an ex-warehouse instructor, depends on age, fitness and medical condition. However, the answer sheet that I went by states between 10 kilos to 25 kilos, which is actually in line with some bit of research I did on the internet, where they're saying that it's roughly what you can carry. But again, it depends on your age, it depends on your fitness, and depends who and what you are. Roughly how long would it take to carry this load for a distance of 10 meters? Well, again, this is going to depend on your age and fitness and medical condition. You know, you might take slightly longer than I might, and somebody else might be able to do a lot quicker than I can. But the answer on the answer sheet states between 10 to 20 seconds, which I suppose you could almost sort of look at is just over, say, about 2 meters a second, which is pretty reasonable, really. Okay, but as I said, that question's a little bit vague. That's the best way I can try and explain it for you. Right, so let's carry on with the questions. Okay. 3 members of the drama group, all about your age, set out chairs in the hall. All chairs are stored by the stage. Each chair weighs 4 kilos. Okay. The next 2 questions again are pretty vague. Okay. I've tried to approach them the best way I can. I've looked at the answer sheet because again, it all depends on age, fitness, and medical condition. However, the answer sheet states between 2 to 5 chairs, which we think about it probably is about what we would do. I mean, so really I'd say don't carry more than about 2 chairs anyway, unless you've actually got wheels. Some people can carry 3, some people can carry 4, but really actually think about no more than 3 really is what you should be doing, unless you've got wheels. Then it's estimating total difference. Okay, well, the way I sort of looked at this one is well, there's 14 chairs across the block. There's 3 trips with 4 chairs 3 times and 1 trip with 2 chairs at the end. Possible distance is 13 meters. So she'll walk 13 times 4 meters, but she has to walk back, so the distance she'll walk is 2 times 13 times 4, which is 104. It's a bit of a vague answer. The guidance I had on the answer sheet was a little bit vague as well. So I've tried to interpret as best I possibly can with this for you. Okay. I'd just be curious to know how you actually got on with these 4 set of questions, which are a little bit vague. But there we go. I've done what I can there. I've done my best to try and approach it for you. Okay. We have another one here. Is how long would it take 3 members of the drama group set out all the chairs in both blocks? Jot down any assumption. So this is an assumption. So this question is a bit freewheeling, really. So this is the way I'd work out. Distance to the front is 2 meters. And again, I'll take this from the guidance of the answer scheme as well. Distance to the front is 2 meters, distance to the back 13 meters, so your average distance is 7.5. It takes the person here 20 seconds to walk with the chairs and 20 seconds to walk back, so time per trip is potentially 40 seconds. 4 trips are required per row. There are 21 rows, so 21 times 4 equals 84 trips. Times 40 seconds, which is 3,360 seconds, 56 minutes for 1 person. That's how I've calculated it. Well, there's 3 people. So the way I looked at it then was, well, okay, 56 divided by 3. So it works at 18.66 minutes per each person. Okay, let's say 20. All right, because you're going to have a little bit of a stop, a little bit of a break. Some walks you're going to walk slower, sometimes you're going to walk a bit faster. So again, I appreciate this is a very vague question. I've tried to again approach it as best I can using the answer scheme that I've been provided with. Perhaps that might be a little bit clearer to you. Again, we'll no doubt talk about this in one of our math sessions, so if you had a look at it, I'd be very curious to know what your thoughts happen to be. Right, something totally different. We're going to talk about rainfall. Something we tend to normally have quite a lot in this country, although we haven't had any much in the past 2 weeks, time speaking on the 7th of April. So, again, just have a little read through. So, I'm just going to jump straight to the question. How much water for flushing the toilet and using the washing machine do Alan and his children use? Well, count the tallies out. So, if you count the tallies for the toilet flush, it comes out 108 times that by 8 litres, gives you 864 litres of water. The washing machine is only used 3 times, so we multiply 3 by 106, or by 65, sorry, gives us 195 litres. We simply then just add those 2 together, which gives us 1,059 litres of water used. So again, it's all about counting the tallies, but then give you your answer that you need to do. And remember, a tally with a line gone through is equivalent to 5. Right, so we're looking at the next part. Find how much water will cost for a year. Well, the water is 0.2 pence per litre. So we take our litres from our previous question. We times that by 52 weeks of the year. Times that by 9.2p, which gives us 11,013.6p. Remember, this is pence. Okay. But I can say now this is how they want the order. Sorry, the answer. The answer's not in pounds. The answer's in pence. So think back to what I say about RTFQ, but also using the appropriate unit of measurement. So they're giving us that. They're not asking us to convert it into pounds. They're just asking it to be left in pence. So that's what you do. Okay, this is a question to be careful of. Particularly note the bit on the left hand side says 1 inch of rain. Right, it's important that you know here, they haven't given you any guidance, so this is something that you're going to have to know, is that 2.54 centimetres is equivalent of 1 inch. Okay, inch being an imperial unit of measurement. Remember that 100 centimetres equals a metre. So, we are given the hint that 1 millimetre equals 1 metre squared is equivalent of 1 litre of water. So we are now looking at our cube down below, and 1 inch of rainfall in a rectangular area measuring 5 metres by 8 metres equal to a cubic metre of water. Okay, here we go. So our 5 times 8 equals 40. So we know that a metre squared is 1 litre, so we know we have 40 litres of water. This is where you're knowing the 1 inch is 2.54 centimetres comes into play. So that is something, then you take that, 2.54 centimetres, you'll times that by your 40 litres. You're then going to times that by 100, which is your square meterage. And that brings you out to the total of 10,160 litres. I agree, it's a bit of a vague question again. But if you can take some time to study it, like I had to do when I looked at this question originally to understand where it went, it does sort of break down into constituent parts. So I suggest that's the question you actually have a reflection and have a look at. Okay. Again, something similar to these questions do tend to appear in the exam, so it's well worth you having a good idea how they get worked through. Okay, so Alan found this form in the workbook about collecting rainwater. Okay, so let's skip down to the question about what depth of rain falls in Durham a year. Okay, we have the graph right here. Now, of course, it doesn't show so well on the computer screen. Okay. Because it's condensed a bit, but actually on the paper this will be a lot clearer. So what you're roughly reading off is the figures that the bars represent. For example, like 116, 15, 39, and so on and so forth. These need to be added together, which gives you 863 millimeters approximately. Okay, it's going to be an approximate answer because you can't determine exactly from the graph. Okay, but this essentially what you're doing is you're roughly interpreting what you see on here. Okay, but again, on the question paper, this will be a lot clearer than I can actually make it on the PowerPoint presentation.